Morning, everybody. So here's today's project. This is, I don't know what you call them, I call it king post assembly. This is from a big sidearm mower. This would be like the ones that the counties use to mow alongside of the road, where it's got an arm that functions something like what a backhoe arm would. Got this king post attached down on the side of the machine with, you know, a double jointed arm with a mower on the end that lets them mow down and up ditch banks, and I think they can flip it up sideways and, you know, like hedge trees and stuff with it too. But anyways, I'll bring you in closer and show you this. But it's got some really crummy little bushings in it. I hate these kinds. Stamped steel, thinny anythings. They give you zero protection if they start going. So I'll bring you over and show you. But anyway, it's got the hole blown. Basically, the arm hangs on it this way, so it's blown out this direction on the top and blown out that direction on the bottom. So I got to weld this thing up and rebore it, but then pretty much every other hole on this machine is shot too. It's severely under-engineered as far as I'm concerned. Just, it's all fabricated components with not enough metal. So I'll bring you over and show you the close-ups of this once. So here you can see just how ugly it is. And you can see it's got thin enough and loaded bad enough it's split right down the side of it there. So here's what I want to do. I want to take, you can see the crack running along through there. I want to take this die grinder with a ball end on it and go in here and chase that through probably just about down to nothing, so that I'm starting all with actual weld in there. And then I'll probably, when I get done welding on the inside, flip it over, V it out hard from the outside then, and go ahead and weld that too. I really want this thing maximum strength. Alright, I've thinned it right out. You can see there's some material left, but what I'll do is I'll weld this up, and then I'll die grind out from the other side after it's welded until I reach my weld, and then fill in from the other side so that I end up with full weld in here. So anyway, we're ready to go to buzzing on it, I think. So we are done doing build up on that side, and here now, this is where I want to come in here and die grind now down and meet the root of my weld across here, and then fill that back in. So we'll shoot a little video here and get this project rolling. Find the right wrench, but we got her tightened up. Another 10 minutes or so, and holes all welded up, and I think we are completely ready to go start setting this up on the boring mill. So let's have at her. Let's go see what Wiggles is up to over here. How's it going, Wiggles? Alright. Wiggles is trying to make himself an adapter so he can mount a diamond cutoff blade on this steam engine driven contraption he's putting together. So he's doing some MacGyver in here. Oh, you're good at it, Wiggles. I gotta go work on my project. You got her. You'll get it. He's a little scared of that parting tool. With good reason. I'm scared of them too. So how's your gizmo working, Wiggles? More power! Maybe you ought to clamp that thing down on that cart or something.
It keeps rocking.
Yeah. A little tipsy-turvy. Alright, Cupie came to visit. Wiggles is fine-tuning his steam engine contraption. Alright, we're going to take another try at this. I didn't have enough relief on the, actually the steel shank. It wasn't even the carbide, it was steel shank, so. Looking and feeling much better. Pretty healthy cut we're taking here. High spots in the welds and everything. Felt it start moving. Hi, Cube. Checking her out? What do you think? You gonna run it for me? Cupie and his mommy came for a visit. So it was cutting pretty heavy. You can see in there we got a lot of weld. I got way carried away putting weld in there. I was overly paranoid. So anyways, problem is there was nowhere for the chips to escape, and it wadded a bunch of them up in there, and I felt it do it. It yanked this thing over sideways on me. So anyways, I've got to get in here and get re-centered up before we do anything, and we're going to quit playing with it that way. I got this big old ragged 2-flute end mill that I keep hand sharpening the end of, and we're going to plunge through there with that and just knock the high spots out. And then once that's through there, I'll be able to go straight to this boring bar, which is what I actually want in there anyway. I was only trying to do what I was doing with the other tool just to hog it out enough to let the boring bar through. So that's 2-inch boring bar, and this is like a 2 1/4, I forget, it's been resharpened, but somewhere around 2 1/4 inch end mill. Now where it's going to be a little funny is I didn't go quite as nuts welding this end up, and I'm hoping that the 2-inch bar will just go through there to start with, but we'll see when I get punched through here if the bar slips through. Alright, we're carving. You keep a finger up against it like this on the table, and you can feel very quickly if anything moves that way. Let's give it a shot of oil in there. Hopefully some of that gets to where it needs to be. Must-haves, we're getting a little smoke now. Some feeding out with the spindle, by the way. 5 thousandths per revolution feed rate right now. You really have no idea how much a kid like that is learning just screwing around with something like that. He's been horsing around with that for days, so. He's learning all kinds of stuff about torque and power transmission and just general stick to it. It takes him, the size rack he's on, probably 2 hours to cut 1 1/2 with that rig, but he's sticking with it and doing it. So, off camera, I tried the 2-inch boring bar, and then I've also got a 1 and 7/8 or 1 and 15/16 one. It's oddball, old timer, but anyway, I've got that one set up with bearing. Neither of those will fit through here, so I've decided we're not fighting that anymore, and I'm going to drop to an 1 1/4 bar. Now, the downside to it is it's not as rigid, but I'll spend more time screwing around trying to make those bigger bars fit through there than if I just start whittling away with the smaller bar. So I'm calling it a night, but we're going to get back at it in the morning, set this bar up on there, and get an outboard bearing support on the end, and get whittled through there. That should make pretty quick work of this whole project. Just get in there and just start blasting through it. So anyways, I will bring you guys back tomorrow, and we'll have back at her again. Howdy, everybody. So, this is the next evening because I got tied up, let's see, I went and put a digital readout on a Bridgeport milling machine, and then went to another shop in Holland. The first one was up in Grand Haven, then I went to Holland and replaced the variable speed bushings and belt on another Bridgeport. So anyways, I didn't get back to this as early as I wanted, but you can see I have set up an 1 1/4 boring bar, so now we have no clearance issues with my weld. I should have just done this sooner, but hey, sometimes you can do this stuff a long time and still not be able to see the forest for all the trees. But at any rate, what I'm getting ready to do is set me up a tool. This boring bar isn't long enough to let me cut all the way through, you know, both ends. I've only got weld in the ends, but I don't think I'd really want to set one up long enough to do that anyways, because you'd have such an outrageous amount of overhang that vibration and chatter would just kill you. So anyways, I'm going to get some tooling set up and we're going to do some cutting. Taking a pretty heavy cut for the size tool and size bar we've got in here, but figured I'd see what we get away with. I feel no movement at all in the part. over to this end. Keep lots of oil on my bearing where it's sliding through there. Not quite sure what's making the rattling noises there, but it's working, so. Feeding out with the spindle at this point. Alright, after trashing my tool a couple of times, I realized I was doing something really stupid, and I was using the second hole down my boring bar for no reason other than just it was like, oh, that looks like a nice spot. Well, that automatically is reducing your unsupported overhang, right? Like I'm further out my bar, so moved back one, which let me move the whole machine up, you know, by the, I think they're 3 inches between holes. Reduced my cut because I started getting my brain re-engaged and realized, like, okay, I'm on an 1.25 inch bar. You can't take, you know, 60 thou on a side off. So we're backed off to like 25 on a side, less overhang, and it's cutting like a dream. Just wanted to show you guys this, if I can get it to focus on it. So it has ever so slightly dulled the edge of that, but basically it's almost as nice as it was when I started in on that hole. So good thing to take note of. Now I'm not, you know, I realize there are a lot of you guys that are professional machinists, so I'm not trying to preach to the choir. It's more just the people that are watching that wonder, like, okay, what's the difference between high-speed tool steel and carbide? So carbide really likes continuous cuts at high speeds, would be kind of a broad generalization. It does not like interrupted cuts very much. And especially it dislikes setups that aren't rigid. You get harmonics and vibration and you just destroy it. And I have a combination here that is just a recipe for vibration and harmonics. I got tons of overhang, I got a small diameter bar, and I was running fairly high speed. So what I switched to is, this is some 8% cobalt tooling steel. Anyways, that's much more forgiving of all those things. What it doesn't like is high speeds, mostly high speeds. It doesn't care much about the interrupted cut. It doesn't care much about the harmonics. It doesn't like high speeds. So I turned it way down so it was turning real slow, ran oil on it as a cutting lube, and just let it gnaw its way through there. And it was, there were places in there it was cutting 100 thousandths on a side. And it just ate it up, came out looking as good as new. So it's just one of those examples where sometimes you got to back up and go old tech, low tech to get the job done. So now that we've got this hole gnawed out, I'm going to pull this bar and switch over to the 2-inch bar so we can really get some work done. Wiggles is running his new and upgraded steam engine arrangement. We put a larger base on the engine with some bolt holes in it so we can actually get her anchored down good. The old girl's getting a workout. Hate to think what my power bill is going to be running the air compressor this much, but hey, he's having fun. So here we are, 2-inch boring bar all set up. I'm just getting ready to set up a cutting tool, do a little math, figuring out what my dimensions are with this larger diameter bar for tool stick out and stuff. So we're about ready to start some cutting. Alright, this is attempt number 1 on my roughing cut with a 2-inch bar. Taking 5 thou per revolution cut rate. I don't remember, what, like 147 or something on RPM. So far I can tell you already it's drastically better than it was. Alright, we're working on the actual bushing bore now. We're taking about 40 thou on a side. I got to cut into a depth of 2.5 inches. It's inconvenient, I'll say, to keep track of depth off from this dial using the spindle. So now I'm feeding with the table so that I've got a digital readout I can watch. I could count revolutions on here, but I don't feel that ambitious when I can just read it off a digital readout on the saddle feed. So Looking good. Alright, we're on finish pass here. We're taking 10 thou on a side. Once you get to the bottom of this bore, we're ready to switch to the other end cut. It's looking real good. No nasty voids or anything in the weld, so we'll be ready to spin around to this end and carve this out. I think the one thing I'll do is go ahead and face the end of this a little bit before I switch ends. Alright, that end's pretty well cleaned up, faced off. Getting ready to take my first, I'll say, witness pass through here. Cutting more than I thought it was going to be. We'll see how she likes it. If it complains, we might have to back out of her a bit for this pass. This ought to be the last roughing pass for the basic tube bore dimension. It's a pretty good cut, so we'll see if she'll go along with this parade or not. And we're going to try and rough our way through there and then come back and we can start taking it to final dimension. About all the chatter you can handle. It gets any worse than that, I'm going to have to back out of it so it'll break a tool. Running C6 carbide, which a little on the brittle side, but it holds up better as far as wear is concerned. So quiet it down a bit. Sometimes it'll chatter just a little bit like that when it's first really sharp, and then once the bit dulls just a little bit, it'll actually quiet up. Loads the tool more is what's going on. Alright, she's carving. We are right on the money, done with that. You can see I don't love the finish in here, you can feel that. What was going on is my machine wasn't feeding consistent. I got something weird going on where it's binding up a bit on the lead screw drive, feeding this direction. You can see it in the digital readout where it, you know, like, it's hard to describe it. You can see the numbers speeding up and slowing down as it's feeding. It's only a few thousandths, but it's enough to introduce, I don't know what you'd call it, an irregularity into the surface. Now, I'm holding that a thou tighter than what it technically needs, so I'm probably making up for it with more crush in the bushing, but I don't love that. I'd like to hone that, but I can't because I'm up against a shoulder. So anyways, for what it is, it'll be plenty good. I mean, remember, we're stuffing these kind of crap bushings in there that are soft steel. Anyway, they're a pretty questionable outfit to start with. But anyhow, so it's good. I just wish that I could make a nicer looking finish. But like I say, I should have shown you on this, but you'll see it like the last digit speeding up and slowing down as it's feeding. It only does it feeding out. You feel it when you put the hand crank on. I think there's a thrust bearing assembly that's out of adjustment in here. But anyways, we got her. So we're going to shut down for the night, come back tomorrow, and we got to pull. Okay, so we're all done with the boring. I just got to do some cleanup with the grinder and get this grease fitting back in here is all we're left with now. So we'll work on a bit of that. grease fitting back in here. I usually intentionally select to drill a little on the undersize when I'm hand drilling for tapping, because you almost always wobble around a little bit and oversize the hole slightly. Good, so I want to see you got a nice tight fit. Test fit it. Hit the booger if this end is just a little tight. Interesting, a little bit tight on the that's what we want though. Beautiful. Wanted them as tight as I could have them and still get the pin through there, and we've succeeded in doing that. So anyways, we've got this one all fixed, and now we get started on the rest of their projects, which I will show you a minute. So let's see here. We got a couple things we had to do. They have a piece of this size tubing that they've welded into a spot, and it took it out of round a little bit, and they need to be able to slide a pin through it. They had this reamer, which basically fits this thing. The problem is these kind of reamers do not, they want to chuck around and bind up, so I'm going to make them a pilot to go on the end of this that runs through that hole is what I'm up to. So we're going to get that done, machine them this tube. This one's getting welded in somewhere else, and it just needs counterbore put in each side for the bushings, and then that'll be ready to go. That's a lathe job, and then they're just going to weld it in. So anyways, we'll get those wrapped up, and they can put their machine back together. Oh, here's all the plunder for this project. So this was undersized on the ID. It was too small to let the pin through, so I just punched through there. I got a big, I went with a 32nd over 3-flute core drill and just punched her through the middle of there and opened it up. So that's why it's pretty rough looking down the middle, but don't really care. It's just clearance for the pin. And then I went in there, and I hate these kind of bushings. You're always taking a wild guess at it. They don't come out to anything that looks like a common nominal size. I do not know what size they think they're making them, but they're not really round. They're split down the sides. So you end up measuring them in 4 or 5 different places and then trying to average it out and figure out what a press fit is going to be. I held them a little on the tight side. They're probably pushing 3 to 4 thou press right now, which is quite a bit on a bushing that size. But like I said, they're real soft steel. They crush easy, and then because they're split, that stupid slat they got down the side of them will kind of crush in too. So anyways, so yeah, bored that from each end, and then this is the bushing I made. So this is a piece of the tube that they're trying to ream out, and what I did is made it so that the bushing was a pretty snug fit on the end of the reamer and floats in here, and I made that out of cast iron. The reason for that is because they're going to be making chips and stuff, and I didn't want it to be something that could gall up in the tube if a chip got in between it. So I was leaning towards aluminum, bronze, or iron, and I happened to have a piece of iron. So, and iron's probably the best out of those 3 choices. Aluminum will kind of wad up. Bronze is expensive. A hunk of iron with the graphite that's in it will slip through there nice, and they should be able to ream it. The trouble they were having is that this reamer's got a long taper on it, and even trying to run it by hand, it was cocking sideways and locking up in the bore. So they should be able to run it through there by hand now and get the job done. So anyway, I'm going to go drop this stuff off and call her quits.